Hello everyone, my name is Hassan and this is a short lecture on supervised versus unsupervised learning. In this lecture, I'll first introduce supervised learning, then I'll talk about unsupervised learning. Then we'll discuss some of the practical issues, the pros and cons, and some practical examples. The main learning outcome of this lecture is to develop a basic understanding of supervised and unsupervised learning. So talking about unsupervised learning, I generally like to refer to it as learning from examples. Supervised learning involves a training phase in which we learn from labeled examples. After the training phase, we have a test phase in which we evaluate the prediction quality of our trained model. And if the trained model makes accurate predictions, we can then go ahead and deploy it into the real world. Looking at an example of supervised learning, let's say you are working for some fruit packaging industry and you are trying to differentiate between or classify apples and bananas based on two attributes. One of them could be the diameter, the other one could be the intensity of the yellow color. If you take 30 apples and bananas and you plot them in this two-dimensional space, this is what they may look like. Now, since this is supervised learning, you know the labels of each data point. You know which one is an apple or a banana. Now, once you have your data, the next thing that you could do is initiate your training phase. And in the training phase, let's say you have a simple line that you're going to use to allow you to classify bananas and apple. So let's say everything that is below the line would be called an apple. Anything that is above the line would be called a banana. Now, this is not a very accurate model because we make a lot of mistakes. So if we move it up a little bit, our performance improves. If we move it further up, our performance, in fact, on this data becomes perfect. Now, once we have trained our model, we can basically go ahead and store the parameters of this model, which in the case of this line would be the slope and the y-intercept of this line. After this, we can initiate the test phase. And in the test phase, any point that falls in the blue region would be called an apple. And anything that falls in the green region would be declared a banana. Now, in the test phase, you would make multiple predictions for multiple unseen data samples, and then evaluate how many of these predictions were correct and how many were incorrect. Now, if your predictions are accurate, you basically can go ahead and deploy your system into the real world. Now, one thing that I want to state before I move on is don't think of supervised learning as something where you have just simple linear models. You can also have much more complicated models like this quadratic decision surface, or maybe even something like a circular decision surface. And the reason that I'm showing you these examples here is just to give you a hint of things to come, because you'll be using these concepts when you actually go in and deal with machine learning models or classification models or supervised learning models in a little bit more detail later on in the advanced parts of this course. Now let's talk about unsupervised learning. With unsupervised learning, we typically do not have labeled examples available. That's generally because labeling the data may be too costly or it may be too difficult. However, this should not stop us from making smart decisions based on the data that we have. And so unsupervised learning, therefore, often entails finding patterns in data without labels. So let me give you an example. In this case, we do not know the labels of the data, but we can clearly see that there are two groups or two clusters in this data. So let's say if we get a point on top, it wouldn't be a wrong guess if we said that this was part of cluster 1. Similarly, if we get a point at the bottom, we might say that it came from cluster number 2. Now, keep in mind that clustering is not the only form of unsupervised learning that is available to us. There's another form of unsupervised learning, which is called anomaly detection. So let's say you have 1,000 transactions of a credit card customer that you have accumulated over 1 year. Now, what you could do in this case is learn the probability distribution of this customer's credit card transactions. Now, let's say one day you observe a transaction which lies way up here. So it's very unlikely that this came from this customer's buying habits. Seems like an abnormal kind of an activity. You could call this an anomalous data point, and in this case, it might actually, in fact, definitely make sense for you to give the customer a call and verify whether they in fact did make that transaction. Anomaly detection is also used in computer security applications as well. Now let's talk about some practical issues. Supervised learning is great if you have label data. Now that's a very big if. There are a lot of situations when labeling the data can be really expensive. So let's say if you're trying to build a speech recognition system like Siri, you would need access to hundreds of thousands of hours of labeled speech data. Now, if you're not a tech giant like Apple, that's something which would be very difficult to get a hand on. So unsupervised learning, therefore, is sometimes the only viable option that is available to you. It may be cheaper as compared to supervised learning. However, it may also be less accurate. But if it's the only option available, then you're going to use that option. Let's take a look at some practical examples. With supervised learning, one example that I can think of is face recognition, which is often employed by companies like Facebook to associate your pictures with your identity. Now, Facebook has billions of images of people, and most of these images are tagged as well. So it's very easy for Facebook to take these images, take the tags, and train a supervised learning system to associate, which can learn to associate the identity of the people with the images that they get. With unsupervised learning, you may encounter it with product recommendation systems that are employed by Amazon.com. So let's say you go to Amazon and you search for a canvas. Now, in that case, you may get two types of canvases. One might be a blank canvas. The other one could be a painted canvas. Now, people who are searching for a painted canvas may also be interested in art supplies, whereas people who get a painted canvas may be interested in getting frames for those canvases. Now, Amazon can look at past purchases of people. So it can create one cluster with items that were bought with painted canvases by previous customers. It can create another cluster containing items that were bought with blank canvases, and then use these clusters to recommend products for people who click on these canvases. So let's say if I click on the blank canvas, this is the recommendation that I get, and it's clearly art supplies, and it's clearly relevant. Now, if I click on the painted canvas, this is the recommendation that I get. Now, it contains a frame, contains some boxes. Now, this is not as spot on as the previous recommendation, and it seems that this has clearly not been done by a human because the frame is not the same size, it's not the same shape as the canvas that I'm looking at. However, think about it from Amazon's perspective. You're getting millions of queries every hour. It doesn't really make sense for you to associate or have human curators work on each and every one of these recommendations or even label data for these recommendations. So it makes a lot of sense to use unsupervised learning. All right, so that's the end of my lecture. These are some of the resources that I used. Thank you very much for listening, and I wish you the best of luck with the rest of your invention in machine learning.